So now we know the pattern for finding a series for any function. We take the derivatives, etc., and fill it into this pattern that we see here. But there are certain series that get used a lot, and there are certain series where it may be very difficult to actually come up with all those derivatives. For example, let's say that the question is find the Maclaurin series for sine of x squared. So let's say I ask for the third degree. So you would have to start by taking the first three derivatives. If I did that, here's my first derivative, cosine of x squared times 2x, not bad. My second derivative, you would need to use the product rule here. So the derivative of the first is negative sine of x squared times 2x times the second plus the derivative of the second times the first. And you can imagine if I had to take the third derivative using the product rule here, and as we keep going on, there's really not a pattern, and this gets very tedious to do. But actually, it's quite easy if you know what sine of x is. So if you know already that the sine of x is x minus x cubed over 3 factorial plus x to the fifth over factorial, etc., then sine of x squared, all you're doing is replacing the angle with x squared. So wherever you see an x, you are going to replace it with an x squared. Divided by 3 factorial, so I'm going to plug in an x squared wherever I see an x. Those are my first three terms, and obviously the pattern continues. So this is the series for sine of x squared, and you would get the same thing if you went through and calculated all these derivatives. So there are a couple series that you will be using a lot, and you will be asked to memorize for the AP test. This is one of them, 1 over 1 minus x, but this really you should remember it as a over 1 minus r. It's a geometric, your a is 1, your r is x. E to the x is a series that you need to memorize. Sine of x is a series that you need to memorize, and cosine of x. So these four should be put on a note card, and these are it only works if it is a Maclaurin series. So you can title your note card as Familiar Maclaurin Series. So anytime they ask you to come up with a Maclaurin series, that's any version of e to the x, sine of x, or cosine of x, you should be doing it from here instead of going through and calculating all the derivatives. So let's go through and work through some examples. So example 3 says find the series for, and assume that we're talking about a Maclaurin, for cosine of square root of x. So if I know that cosine of x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus dot dot dot, cosine square root of x, I'm not going to take the derivatives. All you're doing is replacing x with square root of x. There's no x in 1. I'm going to plug in square root of x here. So really this just becomes x. If I plug in square root of x here, square root of x to the fourth really gives me x squared. And so the pattern continues. So very easy to come up with that series. Okay, let's try e to the x squared. So again, if I know the series for e to the x, so I know e to the x is something like this. And so the pattern continues. E to the x squared is just replacing x with x squared. So wherever I see an x, I'm going to replace with x squared. And that's it. Easy, right? Okay. Okay, the next one, why don't you try the next one on your own? Pause it for a minute and come back and check it. So I know sine of x is this. Oops. Dot, dot, dot. So sine of 1/2 x, you're replacing the x with 1/2, and I would just leave it like this unless you need to simplify it for one reason, because this will also make it easier when you eventually have to write your sigma for this. Okay. The next one is a little bit tricky. It says find a power series for sine squared of x over 2. Okay? You will need to use the identity that sine squared x is 1 minus cosine of 2x over 2, because there's no way you're going to be able to take the entire infinite power series for sine of x and multiply it out. So I'm going to first start with this identity. So I know sine squared is 1/2 times 1 minus cosine of 2x. Here's your double angle. And I know that the cosine of x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, etc. So in order to create this series, Okay, I'm going to start with this piece. So cosine of 2x just means I'm going to plug in a 2x wherever I see an x. Okay, but notice I also need 1 minus cosine of 2x. So 1 minus cosine 2x is really this entire series, but this 1 will disappear, right? Because you're going to do 1 minus that number, and then because you are subtracting everything that comes afterwards, all your signs have to flip. So I'm going to just flip all the signs. Okay, what else do I need? I also need that 1/2 in the very front. So now my final step is take that series and just divide everything by a half. So I'm going to just go ahead and stick a half on the bottom of every term. Plus 1/2, 2x to the 6th over 6 factorial plus dot dot dot. Okay, this last example, use a 4th degree Maclaurin to approximate e to the negative x squared. So without a calculator, there is no way to integrate e to the negative x squared, but I can come up with a pretty decent approximation. I know that e to the x is this. So e to the negative x squared is just replacing the x with negative x squared. And I'm going to stop here because I just need a 4th degree, and this is my 4th degree right here. So instead of integrating e to the negative x squared, which we cannot do with the calculator, I'm going to go ahead and integrate this 4th degree that we came up with. And I'm going to simplify a little bit, so this just becomes positive x to the 4th, 2 factorial is 2. And this we can integrate pretty easily. It's just a polynomial, so this is x minus x cubed over 3 plus x to the 5th over 10. And if you plug in 1 and subtract out the 0, it's 1 minus 1/3 plus 1/10, whatever that value is.